Let's do one more problem where we're comparing two sets. So let's compare the sets A union B minus C and A minus C union B minus C. So let's compare these. We start with our Venn diagram here. Our Venn diagram. Here's A, B, C. So let's start with, let's highlight the set A union B. So we're going to highlight that whole section there inside of either circle A or B. Okay. And now we're going to take and highlight. We're going to do this set difference now. So we're going to look at A union B and we're going to remove C. So you're going to take out any part that is inside of the C circle. So I'm highlighting just the part that was shaded in red, but it was outside of the C circle. Okay. So that's the first Venn diagram. Let's draw the next Venn diagram over here. And again, I have three sets, A, B, and C. So the first thing I'm going to shade in is A minus C. So you're going to take the A circle and you're going to remove the part that's inside of the C circle. And now let's shade in B minus C. So you're going to shade in the part that is inside of B, but not part of the C circle. And then you're taking the union of these two sets. So I'm going to shade in, use my highlighter here for blue, for the union of these two sets. And the union of these two sets, if I highlight it, it would be just cover over any part that's shaded here that has any color at all. So now compare these Venn diagrams. If you look at these Venn diagrams, you'll see that they are identical. And so because these Venn diagrams are identical, what it's telling me is I think that these sets here are equal. So now what we want to do is we want to prove that. Let's prove that these two sets are equal. So our next focus right now is let's prove that A union B minus C equals A minus C union B minus C. Well, remember, if you're proving two sets are equal, there's two things you have to prove. So I'll say that we must prove two things. Remember that showing two sets are equal, that's a biconditional statement. So I have to show that the set on the left, A union B minus C, that's a subset of the set on the right. And then I also have to show that the set on the right is a subset of the set on the left. So we're going to prove these two things. Let's prove the first one. So let's prove that A union B minus C is contained in A minus C union B minus C. So we're proving that first one. And again, when we're doing this proof, we're going to start by outlining the proof. So what does the outline of this proof look like? Well, let's tell me where I start my proof. I would start by taking X to be an element of A union B minus C. And that what will be the end of this proof? The end, I want to make sure and give myself enough space here. The end of this proof will be that X is in A minus C union B minus C. So what does it mean to be in a union? It means that you're in the first set or it's in the second set. All right, so let's go back to the start, and remember what we have to do is we have to fill in this section right here. So let's do that. So let's fill this part in now. If X is in this set here, then what does it mean? It means X is in A union B and it's not in C. But what does it mean to be in this union here? It means it's in one of them, right? So X is in A or X is in B. So here we're again, just like the previous problem, we're going to split up into cases. So case 1 will be X is in A, and then case 2 will be X is not in A. So if X is in A, I also know that X is not in C. So that tells me X is in A minus C, which is great because that was one of the two things I needed to get here. Either X had to be in A minus C or it had to be in B minus C. So let's look at our second case. If X is not in A, well, remember X was in A or X was in B, and X is not in A. Well, it has to be in A or B. It's not in A, so that means X is in B. But I also know X is in B and X is not in C, so that means X is in B minus C, which again was one of the two things I had to get. Okay, so we've completed the outline of the proof, and now what you need to do is write the formal statement of this proof. And this video is kind of long, so I'm going to cut this video off. And then in the next one, I'm going to write the formal statement here for this proof.